Good morning, everyone. So today we're going to be doing the first day of section 8.1, right triangle trigonometry. I posted the entire notes packet blank slides for you, but today we're only going to be covering the first 5 slides, and then tomorrow we'll be doing the remainder. So tonight's homework is actually going to be on Delta Math. You will see it's going to be called PC Right Triangle Trig Review, and that's going to be your homework. So let's get started, and this should be a review, but we are asking you to find the 6 trigonometric functions for the angle pictured. Okay, so the angle that is pictured is theta here, right? So let's label across from theta is the opposite side. Across from the right angle is the hypotenuse. However, the adjacent side isn't labeled, so let's put an X there. Now, how can we solve for x? Well, it's a right triangle, so we can use Pythagorean theorem. Make sure the hypotenuse is always the c value, so a squared plus b squared equals c squared. And you get 36 when you square 6, 100 when you square 10, subtract 36. So you get 64, so then x has to be 8. So let's put 8 there on the side. You also probably could have recognized that this is a Pythagorean triple, just multiplied by 2. But let's go ahead and figure out what is sine then. Sine is opposite over hypotenuse, so that's going to be 6 over 10, which you can then simplify to 3/5. And cosine is adjacent over hypotenuse, so 8/10, which can be simplified to 4/5. And then by doing it this way, by simplifying, you can see that it is in fact a 3, 4, 5 Pythagorean triple. And then theta, tan of theta is opposite over adjacent, so 6 over 8, which simplifies to 3/4. Now we have cosecant, secant, and cotan, also known as our reciprocal functions. The reciprocal of cosecant is sine, so 1 over sine is going to be cosecant. When you do 1 over 3/5 or 1 divided by 3/5, that's basically just multiplying by the flip of that fraction. So 5/3. Same for secant, it's a reciprocal of cosine. So 5/4. And cotan is 4/3. All right, so just to reiterate what I just reviewed on the page before, secant is the reciprocal function of cosine, so 1 over cosine of theta. Cosecant is the reciprocal of sine, so 1 over sine. And cotan is the reciprocal of tan, so 1 over tan. And I also want to go over the quotient identities. Well, quotient means that you are dividing. So what divides to give you tan? Well, we know that that's opposite over adjacent, but we also know that it is sine over cosine. And because cotan is the reciprocal of tan, cotan is cosine over sine. And then a little bit of a blast from the past, we have our Pythagorean identity. Well, remember, right triangle, Pythagorean theorem. If you are thinking of your unit circle, though, we know that we have a radius of 1, and the y is sine, the x is cosine, and you can do sine squared plus cosine squared equals 1 squared, which is 1. And that is your basic Pythagorean identity. And the rest follow from manipulating that equation. So for example, you can divide everything by sine of theta, sine squared of theta, and then you would get the next one. And then you could divide by cosine squared of theta and get the next one, and so on and so forth. But this is the main one that you're going to be working with. So now we want to talk about what it means when you are being asked to solve for a right triangle, solve a right triangle. That means you want to find all of the missing sides as well as angles. Now, in order to solve those, you need to have either two sides of a right triangle given to you, or an angle and a side of the right triangle. So when we say angle, we mean one of the acute angles, not the right angle. And then you're going to make sure that your calculator is in degree mode. So let's quickly go over that. So if you've reset your calculator since last punching in angles, you will have to do this. So go into mode at the top, and then 3 from the bottom, highlight degree, and you should be all set. Oops, probably should have left that, but it's okay. Now, we're going to be solving the right triangle, and we're being told that lowercase b is 2. So that means that the side length is 2. And then its uppercase or capital A is 40 degrees. That means that this is 40 degrees. Well, the easiest value to find is the other acute angle, B, because we know the angle C is the right angle. Well, that means that the acute angles of the right triangle also have to make 90 degrees, since all the angles add up to 180. So we know that angle B plus 40 has to equal 90 degrees. So that means that angle B equals 50 degrees. Which I know you probably could have done that in your head very easily. Now, we need to find the remaining two side lengths. We are given that this value here is 2. Now, it doesn't matter which angle you use as your angle of reference. I'm going to use angle A being 40 degrees. Now, if angle A is 40 degrees is what I'm using, then that means lowercase a is the opposite side. Side C is the hypotenuse, and B is your adjacent. So we're going to solve for A first. If I'm using angle A, opposite, adjacent, that means we're going to be using tan. So tan of 40 degrees equals opposite over adjacent. Opposite is A, over adjacent is that B value of 2. Now, how do I get A by itself? Well, I multiply by 2 on both sides. So that means that A is going to equal 2 times tan of 40 degrees. So if you were to type that into your calculator, you would find what A is. So 2 times tan 40. And it froze, but when we do that, we get that A is 1.68. Now there's only one more value that we need to solve for, and so that's this one right here, 1.68. Now we need to get what C is. I'm still going to stick with angle A, so this time I'm going to be doing to the adjacent side with hypotenuse. So that means I'm going to be using cosine, adjacent over hypotenuse. So cosine of 40 degrees equals 2 over C. Now, if we wanted to solve for this, we would have to first multiply by C on both sides, and then that's gone, right? So now we have C times cosine of 40 equals 2. And now I need to get that C by itself, so I would have to then divide by cosine of 40 degrees. So that leaves you with C equals 2 divided by cosine of 40 degrees. And I'll spare you since my calculator on my computer doesn't like to work when I'm plugged in. But when you type that in, you get that C equals 2.61. All right, and the last slide, we're going to be solving for this right triangle. Now this time, we have two side lengths given and no angles. So we can't just simply subtract one of those angles from 90 to get the remainder. We need to figure out what those angles are. In order to find what an angle measure is, you're going to have to use inverse trig. So let's say I wanted to solve for angle A. Well, with respect to angle A, this is the opposite side, this is the adjacent side, and this is the hypotenuse side. So I have the values of 3 and 8 given to me. So I'm going to be using the adjacent and the hypotenuse, which is cosine. So that means angle A equals inverse cosine of 3 over 8. So just make sure in order to get this inverse, you are not just typing in an exponent of -1. Make sure you hit the second button first and then hit cosine. And then you can type in 3 divided by 8. Or you can put in a fraction if you really want, but you don't need to. And when you do that, you get that angle A equals 67.98 degrees. And that's your value for angle A. For angle B, all you would have to recognize now is that those two angles, A and B, are complementary. So to find what angle B is, you would just subtract angle A from 90 degrees. So B is going to equal 22.02 degrees. So now we found angle A and angle B. The only thing we have left to solve for is the side length of lowercase b. Well, we are more than welcome to use trig to find that, but you don't have to because you have two sides of a right triangle given to you. So we can just use Pythagorean theorem. Just make sure that 8 is your hypotenuse in that equation. So 3 squared plus b squared equals 8 squared. So C has to be your hypotenuse. 9 plus b squared equals 64. Subtract 9 from both sides. You get b squared equals 55. And then square root both sides. You get b equals the square root of 55 for an exact answer, which then, if you were to type in, you would get the approximation of about 7.42. Now again, you definitely could have just used trig to find b as well, but it's good to use different methods at different times. All right, guys, if you have any questions, please don't hesitate to email me or sign up for office hours, and make sure, again, that your calculators are all in the degree mode. And tomorrow we'll pick up where we left off. Thank you. Bye, guys.